My name is Katy Börner. I'm at Indiana University. I'm a professor here in the Intelligent Systems Engineering department, and within SenNet and HubMap, I'm leading the MCIU, which is one of the two mapping components inside of the technical core.
Please give a brief overview of the research you and your team perform.
So my team is specialized in data visualization, and we work with many clients that have personal or professional data sets, and we help them analyze this data, model this data, ultimately create temporal, topical, geospatial, and network visualizations of that data. But we also implement tools so that people don't just get the visualizations, but they can make their own visualizations, not just fish, but a fishing rod, so to say. And that we have been doing since 27 years here at Indiana University. And in addition to making lots of data visualizations, we also like to make atlases. So there's an entire atlas trilogy. The most recent book is the Atlas of Forecasts. And these are large coffee table books with a lot of maps and a lot of explanation on how these maps are created. And the first atlas was the Atlas of Science, how these maps of science that show our collective scholarly knowledge come into existence and how they are used. The second atlas was the Atlas of Knowledge, how you can derive knowledge and insights and even wisdom from some of these maps, and how you can improve your personal and professional decision making. And the most recent atlas is the Atlas of Forecasts, because many people want to kind of test run the future before they sign a check or commit to being part of a team or project, or commit funding to a certain area, or prioritize highly a certain line of research. And so it's very important to also embrace computational predictive models that can help us to use prior data and today's data to kind of help us understand what might happen in the near future with high or low probability if you implement certain steps. And so that line of research is near and dear to all of our hearts here. And so I love to see SenNet embracing some of the computational predictive models, embrace machine learning, embrace large language models, because ultimately a map of the human body cannot be built using just human intelligence alone. We need to combine human and machine intelligence and lots of highest quality data sets. And then we have to communicate the results of that model and also the internal workings of that model to different stakeholders, to people in wet lab environments, to people in computational labs, to ultimately clinicians and physicians and anatomists and pathologists and many others that can really make a difference in how we live our lives in a healthy way. And largest ambition maybe is to also communicate it to anyone, so that we don't even get sick, so that we better help ourselves and our bodies to stay healthy and to live healthy and fulfilling lives. And if things go wrong, then maybe, just maybe, we need some personalized intervention.
What drew you to the field of senescence research?
So I'm an engineer, electrical engineer, trained in Germany, and I came to the US 27 years ago. Started here at Indiana University, a beautiful town, a great school of music, just a wonderful give and take between the town and the university here. Also, we live at a lake. I mean, it's a beautiful environment to do research and to also have a family and grow a team and do productive work. But as an engineer, I like to empower others, and I like to build tools that actually work and make a difference in people's lives. And so from the beginning of my time here at IU, we were not just doing data visualization research, but also tool development. And these tools, again, resulted in a number of ways that people can render their own data in meaningful ways, but ultimately also in this Atlas series. And about 8 years ago, we hosted IEEE conference here in Bloomington, Indiana, and a number of NIH representatives were also present and invited. Among them, Zorina Gales, and she gave one of the two keynotes and talked about the mapping of the human body. And we had very interesting discussions of how we could do that, what kind of latitude, longitude system could be used. Maybe the vasculature could be one way to have latitude, longitude systems that interlinks the different scales and that also interconnects different organs and can be used to have an address system for most of the cells in the human body. And from there, she shared the link to the HubMap call for proposals. We applied and we got the award and then became part of HubMap. And then I think HubMap did very well in creating a portal and at the beginning of a human reference atlas. And now the Hive team is also creating the data core for SenNet. And there are many, many synergies and not just SenNet benefiting from HubMap, but also HubMap benefiting from SenNet. So I love to see that give and take between those different consortia. And I think that makes it all much more efficient across these consortia, because there is value in comparing the aging body with the healthy bodies that is typically looked at in HubMap. And then also in SenNet, you now are studying what the impact of certain interventions is. And that, of course, is really relevant also for understanding why we see certain structures in the human body, because they serve certain types of functions. So in SenNet, for instance, we are working with other experts on a so-called 5x5 study, where we have 5 different organs and 5 different ways to induce senescence. And these organs initially come from mice, but later we will use the same organs from human. They are taken as experts. So for instance, you can take skin biopsies and keep those human tissues alive for, I think, up to 10 days. And of course, that's magic that not my team can do, but that is other experts within SenNet, which are trained in doing this correctly and efficiently. And then what we plan to do is to have assay types taken before the intervention, before senescence is induced, and then also 2 times after senescence is induced. But now you have a comparison across these 5 organs for the very same interventions in the same environment, so that it's actually much more comparable than if 20 different teams would do that. And we will have it for mouse data and for human data. So these kind of experiments are, I think, critically important for understanding how senescence comes into existence, how it changes. Again, we have 2 time points after induction of senescence, and also how it changes between mouse and human data, for instance, and what differs across organs also.
In your opinion, what are the greatest challenges to senescence research?
It's a huge challenge to map the human body. So you're going from a meter size, so 1.5 to 2 meter sized human body. Some people are larger than 2 meter, but meter size, down 10 scales of magnitude to the biomolecular level. So you basically start at ground zero and then you zoom in by a factor of 10 and then 10 times that, right? And so just communicating the enormous scale differences between organs down to functional tissue units, down to cell, down to the protein level is just really, really challenging if you want to build interfaces, if you want to communicate to each other at what level you're working and where your research is. These different levels also have very different temporal dynamics. Things unfold very rapidly and quickly on some levels and rather slowly in other levels. And so just wrapping your mind around all of this is difficult. And then there comes the data integration challenge. In SenNet, we have many, many high-powered teams which are generating data. And some of the data sets are happening at the kind of functional tissue unit level, some at the cell level, some at the molecular level. And again, it's non-trivial to combine data sets from different labs, to cross-search these data sets across organs, across different assay types, which we have many for in SenNet, and ultimately to holistically combine these data sets and insights across scales to really get us a holistic understanding of the human body. And oftentimes, disease or a healthy state of the human body is not just happening at one level, it's really across many, many of these levels. And getting not just an inventory, but a computational predictive model of how that really works. That's the challenge here.
What would you tell students and junior investigators who want to research senescence?
I think it's a marvelous opportunity to be part of such a big team, very interdisciplinary team with experts from so many different institutions, and still you can talk with anyone because it's a very open environment. SenNet is very special in that it welcomes and has many young investigators attend the regular all-hands meetings. And there's also the NIH and Chan Zuckerberg supported Junior Atlas Builders meeting that happens every year. And that brings together 100 to 150 junior investigators, not just from HubMap and SenNet, but from 6+ other consortia, and then also now the Chan Zuckerberg effort. And it's, I think, really important for students to understand how to operate in these big science projects, which are not a single R1 with a team of 5 to 10 experts, but now you have 350 colleagues, right? So how do you learn where your place in this entire team is and how you can effectively contribute, whom to talk to if you have a meeting where all of these experts meet? There's only so much time you have, so which break to use for what kind of meeting? But then also to understand ultimately how to learn from these many different experts which run their teams in very different ways, have different ways to publish, to create their own career trajectories over the landscape of science, but then also to create networks that last a lifetime. And I think these networks are so important for not just accessing data and tools and algorithms and expertise, but also for having a good balance between personal and professional lives. And I think people have different ways of arranging their lives this way. And of course, there are different stages in life. It's different if you have 2 little kids or 2 teenager kids or an empty nest. So it's very, very different what you will experience in your daily life. But then there are many things that are common across these teams. So for instance, being a postdoc is a certain stage in your life, being a tenure track junior professor is a different stage. Being a full professor, what do you do then? How do you keep up your research and not just get become an administrator, even though administrators are very, very valuable and important and needed as well. But I think in the entire mix of all these different personalities and all the different disciplines that are coming together to work on this very challenging project, I think you will learn a lot more than if you would be part of a smaller team. And I think it's good if students go from one team and maybe do a summer internship in another team or start to collaborate across teams. I think you will learn for your life. And that is really, really valuable ultimately for deciding what kind of leadership style you might like to have or which kind of career trajectory you find best fitted for your interests and your needs and your personal situation. And so again, I highly encourage students to talk not just with their own team members, but talk across, try to have summer internships, and really embrace the networking opportunities that these big teams support. And also consider going to the Junior Atlas Builder meetings, which are just magnificent. They have a lot of cool speakers, and it's a great community of junior investigators that is emerging there.